All right, exponential functions. So we're going to remember, continue talking about graphing exponential functions. All right, now remember, an exponential function all right, so remember, an exponential function has this form, f of x equal b to the x. Okay? And what do we about the base? The base must be what kind of number? Positive, but it cannot be what number? 0 is not a positive number. It cannot be 1, so it cannot be the positive number 1. Now, x can be any real number. Okay? All right, so what we did yesterday, though, was right off the bat, you now know about something called horizontal asymptotes. So this is part 2. The part 1 is where we really saw why does an exponential function have horizontal asymptotes. We also saw how to determine the domain, and we also saw how to determine the range. All right, so all that was in part 1. Part 2 is just a continuation. All right, so let's look at this example. So let's go ahead and graph h of x equal 2 to the x minus 5. 2 to the x minus 5. Now, as we go through this as we go through part 2, I'm going to use some terminologies that's going to help us when we get into graphing some other kind of functions. I want to go back to the ones we did yesterday. So if you look at the ones you did yesterday, we started out with 2 to the x. We started with 2 to the x. And so 2 to the x had what horizontal asymptote? The y equals 0, the x-axis. Okay? Then we graphed 2 to the x plus 3. And it had what horizontal asymptote? Y equals 3. What I want you to notice is that both of these had the exponential part being the same, 2 to the x, right? Except one had plus 0 and the other one had plus 3. And so basically what's happening is that if I took 2 to the x plus 0 and I shifted it up 3 units, then I would get this graph. All right, so 2 to the x and then 2 to the x plus 3. I can get 2 to the x plus 3 by taking 2 to the x and shifting everything up 3 units. Because notice if I shift the horizontal asymptote up 3 units, does it become this one? And if I shift this graph, look, every point here, this point right here, if I shift it up 3 units, 1, 2, 3. 1, 2, 3. 1, 2, 3. See what's happening? So that's going to be the idea of translations when we talk about translations soon. So we're going to kind of use some of that terminology in part 2. So if I graph this one, 2 to the x minus 5, and I look at 2 to the x, the graph of 2 to the x, how can I get the graph of 2 to the x minus 5 from the graph of 2 to the x? Bring it down 5. Shift everything down 5. So what you're going to learn soon is that there's something called a vertical translation. Going up or going where? Down. So that plus constant is a vertical translation. So you either move it up or down. There's something called horizontal. It's a little bit more difficult for students, but vertical is pretty easy for students to see. All right. But we're going to do this using a t-table. And listen carefully how you're going to do this. Right away, based on our discussion from part 1, you know the horizontal asymptote. What is the horizontal asymptote? What are you going to write? Y equals negative 5. You know the domain. What's the domain? Negative infinity to positive infinity. That's the domain. Okay? Now to find the range, you probably already know the range based on what we talked about yesterday. But remember, we also mentioned this yesterday, that are all exponential function, are all the graphs going to be above the horizontal asymptote? No. There will be situations where it will be below. Right now, they're going to be above. So if I'm telling you they're above, then can you tell me what the range is? -5 to infinity. Parentheses. All right. Now, if you couldn't tell me that, then when we graph it, look at the graph. You'll see that it is -5 to infinity. All right, so let's graph this one. Now, here's how you're going to graph it. First thing you're going to do is graph the horizontal asymptote. What's my horizontal asymptote? Y equals -5. So y equals -5, put a, what kind of line? Dotted. So kind of like this. Dotted line. Okay? Now, listen carefully. Since my domain is all real numbers, I can let x be what number? 0, which happens to be what? That point would happen to be the y-intercept. So, all exponential functions have a y-intercept. All exponential functions have a y-intercept. Did the ones we did yesterday have an x-intercept? No. But they all had what? A y-intercept, and the reason is because the domain is what? All real numbers. So since the domain's all real numbers, I can let x be 0, because 0 is in my domain. And when you let x be 0, what is it that you're finding? The y-intercept. So you find the y-intercept. All right, so let's find the y-intercept. So you just plug 0 back into x. So I get 2 to the 0 minus 5. What's 2 to the 0? And what's 1 minus 5? -4. So I'm going to plot the point 0, -4. So notice the steps you go through. The first step you're going to do is graph what first? The horizontal asymptote. Then you're going to plot the y-intercept next. Because if we go back to what we did yesterday, the first thing I always found was the point where x is 0. So then I plot the y-intercept, so the y-intercept is here. As we go through this, and as we talk about this, you're going to learn that this exponential function that we're about to graph is an increasing function. It's going to increase. So meaning that if I have my y-intercept, then I know it's going to do this. Look what I'm doing. It's going to do this. Remember, exponential functions rise or falls rapidly, right? So it's rising rapidly. And on this side, it's going to go towards the what? Horizontal asymptote. So do that now. Do this part, not the rising part, but do this part right here, right away. So it goes towards it. Does it ever cross it? No. Now, what I need for you to do, though, is actually make this part a little bit better. So let's plot some points. So give me some numbers to the right of x equals 0. 2. So if x is 2, I get 2 to the second power minus 5. What's 2 to the second power? And what's 4 minus 5? -1. So I'll plot the point 2, -1. 2 more points. Give me another x value to the right of 0. All right, if x is 3, I get 2 to the third minus 5, which is 8 minus 5, which is 3. So I get the point 3, 3. And you want to use 4 now? All right, if x is 4, I'm going to go ahead and put that here. That's 2 to the 4th minus 5. What's 2 to the 4th? What's 16 minus 5? 11. All right, and then this is what you have now. Watch. 4 11s here. Remember, we said it rises rapidly, right? See how it's rising rapidly? Do the best you can with drawing this. There's your graph. You're done. So all you do is draw the horizontal asymptote. Then what's the next step? Plot the y-intercept. And then you know at one point, part of the graph is going to go towards the horizontal asymptote, but the other part's going to rise or fall rapidly depending on whether it's above or below the horizontal asymptote. Notice this one though. Does it have an x-intercept? Yes. And the reason it has an x-intercept is because the horizontal asymptote was located below the x-axis and the graph was above the horizontal asymptote. There will be situations where you're going to get this kind of graph, where it's below the what? The horizontal asymptote. All right. All we've done so far is where the graphs were above. Now notice, can you tell me specifically what that x-intercept is? Can you tell me exactly, rephrase it, tell me exactly what it is? No. You will though, to do it, you have to use logarithms. You have to use logarithms. All right, so that, now you can tell me the range. What's the range? Goes from bottom up. -5. Now, does the graph ever touch it? No. So I'm going to use parentheses. So the range is -5 parentheses all the way to what? Infinity. What's the domain? In fact, all exponential functions have the same domain. Negative infinity. And again, what's the horizontal asymptote? Y equals -5. All right, let's look at this one. Suppose we had this now. Listen carefully. Suppose we had f of x equals 3 to the x. F of x equals 3 to the x. All right. Now, from there, based on part 1, you can tell me what the horizontal asymptote is. What is it? Y equals 0, which is which axis? The x-axis. So the horizontal asymptote is y equals 0. So I'm going to go ahead and graph it. So remember how we did this? We just put kind of like you can actually see those dotted lines on the x-axis, like that. Okay? Then what's the next thing we need to find? The y-intercept. So since the domain is all real numbers, -infinity to infinity, x is in that domain, x equals 0 is in that domain. So when I let x be equal 0, what is it that I'm finding? The y-intercept. So if x is 0, what's 3 to the 0? 1. So I found my y-intercept. So my y-intercept is 0, 1 as an ordered pair. Right here. Okay? Now, what I would then do is pick a couple more numbers to the right of 0. So give me an x value to the right of 0. 3 is going to be 27, right? So I don't have enough room. So let's say 3. Let's say x is 2. So I get 3 squared, which is what? 9. So I get 2, 9, right? So 2 9's here. And if I let x be 1, I get 3 to the first, which is what? 3. So 1, 3 is here. All right? So you know what happens to the left side of that horizontal, you know what happens to the left side of that y-intercept. What happens here? Gets closer and closer to the horizontal asymptote. And on this side, you got to say it rises what? Rapidly. So do the best you can with making it look like it rises rapidly. And so there's your graph. Notice how quick it becomes since the discussions. So given these exponential functions, you can graph them very quickly. So this right here is the function 3 to the x. Now you can tell me the range. What's the range? 0 to infinity. Parentheses 0 to infinity. It's parentheses 0 because the graph never touches the horizontal asymptote. We saw that yesterday, that this will never be 0. Your y values, if you do the t-table, will there ever be a y value of 0? No. Okay? All right, now let's look at this one. And I'm gonna graph the next one in the same plane. So let's suppose I want to graph this now. Let's call it g of x. G of x equals negative 3 to the x. G of x equals negative 3 to the x. What is the base? What's the base? 3. We had the discussion yesterday. You already forgot about the base. The base can never be negative, right? That was part of the definition of an exponential function. The base has to be positive, but it cannot be what positive number? 1. We talked about the fact that if I wanted negative 3 to be raised to the x power, it would have to be where? In parentheses. And it can't be because the base can never be negative. I mean, you'll understand later in another problem part 3 why the base can't be negative. So the base is just 3, right? Okay. But you can still tell me what the horizontal asymptote is. What's the horizontal asymptote? Y equals 0. So it's the x-axis, right? So here's my dotted line. It's the same dotted line as the previous one. What's the domain? Yeah, domain of all exponential functions the same. I can use any real number for x. But what x value do you want to use? What x value do you definitely want to use? 0, because when you let x be 0, what is it that you're finding? The y-intercept. So when x is 0 now, listen carefully. When x is 0, I get negative 3 to the 0. What's 3 to the 0? 1, so this becomes a what? Negative 1. So my y-intercept is negative 1 this time. Based on that, based on what we just said, where is the graph going to be located? Above or below the horizontal asymptote? Below. All right, so let's talk about part 1 and what we did a while ago in part 2. All the graphs were above the horizontal asymptote, and all of a sudden it's below now. What do you think made it go below the horizontal asymptote? The negative in front. So that negative in front is called a reflection. So you're going to learn that word in terms of translation. So we're talking about translations with this as well. So it's a reflection. So the negative reflects it about the horizontal asymptote. Okay? So instead of being above, is now reflected and is going to be located where? Below. So if you think about it, you see that 3 to the x? This is a graph of 3 to the x, right? If I put a negative in front, what does that negative do to this graph right here? Reflects it about the horizontal asymptote. So then it'll become this. It will look like this. All right, so let's plot some points. So give me another value for x. You could use the same ones we had earlier. What do you want to use? 2. So if x is 2, I get negative 3 squared. But that's not positive 9, that's what? Negative 9. So I plot the point 2, negative 9. So look, guys, in the previous one, it was 2, 9. Now it's what? 2, negative 9. So here's that reflection. And then in the previous one where I had 1, 3, I'm going to end up having what? 1, negative 3. And I will. If you substitute 1, notice what I get. Negative 3 to the first. And what's 3 to the first? 3, and then so it becomes a negative 3. So 1, negative 3 is right here. And again, on the left side of that Y-intercept, it's getting closer and closer to the horizontal asymptote. And then over here, we don't say it's rising rapidly. Now we say it's what? Falling rapidly or decreasing rapidly. So it's decreasing rapidly. So you see that symmetry right here? So this right here is the graph of g of x equal negative 3 to the x. Okay? So we're going to do a few more like this again next class period, and then we're going to start talking about logarithms. Because that is going to be on test 3 in your final. All right, so oh, yes, thank you. I forgot about that. Thank you. So the range, so remember when talking about the range on one of your worksheets, and I think it was on test 1, I can't remember, but you always go from bottom up, right? Yeah, it was on test 1, because the circle, you have to talk about the linear range of a circle. So you go from bottom up. So notice this, the g of x function, the arrow's pointing down, so it's pointing towards what idea? Negative infinity. So I'm going from negative infinity all the way to what? 0. Okay, good. So your range, the range here is negative infinity to 0. Negative infinity to 0. Okay? All right.